Bit about me. So I'm Sam. I'm based out of Milwaukee. I'm a customer engineer with Google Cloud, and my main client is Kohls, which is one of the reasons why I'm speaking of Kohls. And just a simple fact about Milwaukee. I was driving on Monday, and on the radio, they actually said Milwaukee hadn't reached 70 degrees Fahrenheit for 180 days. So that gives you an indication as to how cold that place is. I just thought I should share that with you. So yeah, so EDW migration journey. So a couple of quick things before we get started, because I'm going to forget to say this at the end of it. At the end of the session, if you have questions, please come up to the microphone right here, all right, so we can all hear you. And the second is there's also a survey that we would love for you to fill out. So if you could do that after the session, that would be much appreciated. Right. So problem statement, why are we here today? We are trying to talk about how do you take your data warehouse, on-prem, and move it to the cloud with sort of minimal disruption, all right, make sure you still have security, and make sure that all your teams get as productive as possible, as quickly as possible, right? So there's certain elements to this, and obviously this is not going to hold for everybody, but there's certain broad strokes you can look at. So for instance, you have to look at speed of adoption, right? And one of the key things is that if you have a bunch of people sitting around and things go offline, well, it can cause significant disruptions to your business, right? So can we get this up quickly? Can you get it running quickly, right? And can they be productive as quickly as possible, Then scale. How do you scale as needed? Like, how do you scale elastically? So as I mentioned, Kohls is my customer, right? It's in the retail space. You have a certain seasonality of data, right? You have a certain seasonality of needs of data, right? And can your data warehouse help you manage that? In other words, can you scale appropriately? And that's really important because you also have to maintain, not only should you be productive with the data, but you should also be able to, manage your costs, right? Insights analysis, how quickly can you, because when you're moving your data warehouse, all right, from on-prem to cloud, well, you have certain processes already in place to help you be productive with that data, right? So, can you move those workloads over quickly, efficiently, and make sure that, you can also empower new kinds of workloads, right? So something more modern comes along, or something more, let's say you are diving into the AI space, can your new data warehouse, help you deliver on those workloads, all right? And security is paramount, all right? So you want to make sure that only people who have access to the data, all right, should have access to the data. You want to make sure that, that the needs of your end users also are met, all right? So privacy is maintained. And, these are sort of the broad strokes when it comes to what you need to consider when moving your data warehouse, say, to the cloud. So most of you are here in the room because you probably have some, at least, familiarity with how an EDW works, right? So this is more of just sort of a level set, right? What is a data warehouse, right? The easiest way to think of a data warehouse is, think of it as your central repository where you can just dump a whole bunch of data in, so that you can derive insights out of it, right? Now, what it means in terms of the in terms of particular, will differ from system to system, but in general, that's the intent of data warehouse, right? Who is it meant to serve? Well, that depends on your organization, but in general, you have a bunch of analysts, you have business leaders, you have people of differing needs who need to get insights out of the data, right? What is it supposed to enable? Well, fundamentally, it's a driver of business, right? That's the key requirement of collecting the data and analyzing data in the first place, right? So you cannot keep, that is one of the first things that you got to keep in mind is that how do you enable business decisions to be made, and what it can look like. Well, so I got a bunch of arguments with a whole bunch of people about what is a representative slide for this. So, none of us could decide as to, a common theme. So we decided, let's go with the magic of Wikipedia. All right, and where a whole bunch of other people can argue about it, and come up with something that is rather simple. As you can see, you got a bunch of data on the left-hand side. All right, gets into staging kind of area. All right, and gets ingested, and you have sort of different data marts which are aligned to specific business needs. All right, and you have sort of different purposes that those data marts in turn can serve. So it's sort of, again, large volumes of data, right, that you wrangle, get it into a central area, right, and now that can be piped through to serve different business needs, and different people can sort of gain different insights out of it, make different business decisions out of it. So now, we talked about just what an EDW is, right? And one of the big reasons that we are talking about why do you want to, move to the cloud? Well, there are some reasons for it. Because if there weren't any issues or challenges, right, you wouldn't need to sort of do the migration in the first place, right? So one of the first things that we have to deal with in today's world is that the amount of data and the kinds of data you're dealing with is rapidly changing. So not only do you have to accommodate for the amount of data, but the sort of the kinds of data and the speed at which it's ingested, right? Now, one way of handling this is sort of over-provision on your data warehouse, right? This is where the seasonality of the data actually has a significant impact. Because if you overscale, right, to handle those spikes, well, now you're stuck with a bunch of infrastructure sitting around that is underutilized most of the time, which is not efficient. The other way is you under-provision and say, let's just ignore the spikes. And that's not going to work either, right? Is it responsive to the needs, right? How does it adapt? As you have more and more people coming in, say, with different ideas, right? And they want to try out stuff, can your data warehouse accommodate their needs as well, right? Can it be faster? Can you produce your reports faster so that people can make decisions faster, right? Different kinds of workloads, right? So in some cases, let's say that you're doing a bunch of aggregate analysis, great. But in some cases, say you want to, create a new data set out of it that is more suitable towards, say, machine learning, right? So can it actually, accommodate that? The other thing that I've seen in the field is this, that it's sort of a victim of its own success. When you bring all the data in, you go in and you make this significant investment, and now you have this, this central repository that is enabling all these business decisions. Well, the expectation is that it continues to do that over time, right? And now suddenly, 2 years down the road, you say, we need more capacity, or we need, it's no longer providing the kind of results that we're used to, So it's almost as if, it was transformational, but because now the expectation is so high, it's hard to sort of keep up, especially in sort of a staticky kind of setup that a traditional on-prem is going to be, right? And then, which goes to, can it meet our needs 2, 3, 5 years from now? Are you going to have the same conversations over and over again with your business leaders saying, oh, we need more capacity. Oh, we can't run these workloads. We can't, can it still deliver over time, right? And these are some of the common refrains that we see in the field all the time, which is why, I would like to now bring in Kohls, Jazz from Kohls, who went through this, in real life.
So thank you, Sam. First of all, my introduction. I am Jasvinder Singh. I'm a senior manager of big data analytics at Kohls. And thank you, Sam, for reminding that we have to go back to the 40-degree weather after enjoying the 70-degree weather over here. So in most of the enterprises, the analytical ecosystem has been built over past several years. And over the years, we have collected different systems. And more recently, in the last few years, most of the companies have also added big data and Hadoop to their ecosystem. So let's kind of talk about why did we even need so many systems to start with. So the main factor was cost. So as we kind of brought in these kind of technical stacks, and they had kind of fixed capacity. So we, based on the cost and based on our use cases, we bought some fixed capacity. And as we started working through the years, the capacity was not enough because we needed to solve more and more use cases. And so we ended up bringing more of these monolithic solutions. And some of the solutions that were brought in were for technical capabilities. So some of the use cases needed a different system to be brought in. So at the end of the day, we had data coming in from our source systems and landing into different warehousing systems. And since we could not bring in data into a single system, we basically had the need of exchanging data between the systems. So a lot of data was being copied across these systems. And at the end of the day, we had basically arrows going in every direction that you can imagine. So just to kind of highlight what are the issues that we deal with architecture like this. We had disparate data sources for enterprise use. We had inconsistent analysis, and decisions were inconsistent because the data was in different systems, and as it was copied from one system to another system, some of the data quality things were also kind of having issues with. It was kind of difficult to access the data across different platforms. So let's say you needed data from 2 of the systems and I have to build a report. The only way I could do that is basically copy the data from one system to other system. And also, it was very difficult to understand the available data within these systems. And if you're looking for data, it was kind of a scavenger hunt. And there is like very few people in the enterprise who know where to get the data from. And the other problem that we were having was that there was no common understanding of the definitions and the measurements of the data within the warehousing systems. So overall, we had a big opportunity that we could basically go for and solve it in our future use cases. So in our traditional warehousing system, we had these characteristics that are kind of limitations. So you can see on the left-hand side, we had to, as we brought in data into our ecosystem, we had to structure it first. And the reason we had to structure it first is because we cannot just bring in anything and everything. And the reason being, it is basically fixed capacity. So there was a lot of time spent upfront to structure the data before we ingested it and brought it for the analytical purposes. And over the years, as I said, right, we brought these monolithic stacks. And as we are working through different use cases, one stack would not solve the problem, so we had to bring in some other stack to kind of solve the newer use cases. So at the end of the day, we had some of our challenges on-prem were we had a very complex operations in our data centers. We had these multiple stacks which were kind of just talking to each other, exchanging data, and it was kind of becoming more complex for us to kind of support in our data center. And even with all of these different stacks, it was very difficult to keep up with the data growth. So our new approach, or the new way of delivering the warehouse, is that we are going with kind of a flexible structure where we can get in any kind of data. So we can basically get in structured data, semi-structured or unstructured data, and we can ingest it and then analyze it and then structure it based on our needs. And the ecosystem will be with dynamic capacity, so we can add capacity as needed. And it is kind of an ecosystem which is enabled by the bunch of services which can basically solve all our use cases rather than just moving the data from one system to other system. So, so in terms of advantages, we basically had faster speed to market. We basically enabled a bunch of services, and we were able to quickly stand up and deliver some value. Our new approach is elastic and also managed, so that we don't have to deal with all these complex infrastructure operations. So here is how we are planning to build the single source of truth in the Google Cloud BigQuery. So this is basically Kohls data lake in BigQuery. So as you can see, we have different systems on the left-hand side, similar to what we had before, and we have data coming in. It can be any kind of data, whether it's a batch or real time, and we are assembling all of the data in Google BigQuery, and then making the data available for all of our use cases here. So some of the benefits of using an architecture like this is we have basically a single source of truth, and all the analytical use cases are driving the value from the single warehouse in BigQuery. So also using this architecture, we have enabled self-service. So we have provided the decision makers with easy access and readily available data, which is secure and clean. Along with clean data, we have provided our business users with some data discovery and visualization tools, which will help them with speeding up the decision process. And since the team is not busy with just copying the data from one system to other system, we have started focusing on some of the advanced analytics. We have started shifted from structured reporting to kind of more actionable insights and predictive analytics. And since, as you can see, the data is in a single system, we are now standardizing the business metadata and the attributes and the metrics across the organization. So our approach for building this has been very simple. So we have been building a parallel environment in Google by channeling all of our existing sources that are going into the traditional warehouse today and channeling them to go into BigQuery. So as we bring and land all of the data into BigQuery, we are working with our business partners and prioritizing how they would like to kind of cleanse and start using the data within BigQuery. So I think so as we kind of bring the data and we kind of cleanse it, make it available, we have started to solve certain use cases that were being solved with our previous solution as well. But now we are able to solve some other use cases which totally needed a different stack, like marketing operations is also leveraging this stack, and also recommendations can also leverage the stack. So, and as we are delivering the data, we are also doing some comparison between on-prem and cloud, and we have tools that we have built to kind of showcase that the data which we are assembling in BigQuery is higher quality, and also it is delivered with lesser amount of time, and it can be leveraged for analytics plus other use cases as well. So here is the logical architecture slide that we have been using. So, so going from bottom to the top, we have different sources of data coming in. We have external data sources, and we have internal data sources. So we are landing the data using either like file transports or reading real time with Flume or getting it into Kafka. And we are landing all of the data into a BigQuery staging area where we are applying some transformation logic, some of the business logic, and making the data available in the certified data sets. And in some cases, we might be creating some enterprise reporting structures which are being leveraged by the different reporting tools. So I think the key thing here is that all of this is being done in BigQuery. So we are not really leveraging a lot of other tools to deliver the data. although you can see that we do have a little bit of Dataproc, and that is being leveraged for some advanced transformation use cases or certain use cases where we have to protect the data differently. So we do have some Dataproc and Spark that we are leveraging for that, but generally speaking, those use cases are less than 5%. So using this architecture, we are basically enabling faster access to the data for Kohls analytical communities. We have increased the speed and efficiency of the data delivery, and also since it is a single kind of stack, it is very easy to facilitate the governance and ensure the data quality. And we are using data security using some of the encryption that BigQuery provides, and also managing access using the fine-grained access control that are in BigQuery. So overall, this is kind of standardizing the data architecture across Kohls analytical communities. So at a high level, the data that we are bringing into our warehouse is primarily real-time sources, or it is kind of the batch sources that are coming in. So, so in case of the batch sources, we basically land the data in Google storage in the raw state. And as I discussed in my previous slide, most of the data can directly go into BigQuery. And in some cases, we are using some Spark, and it's a lightweight application which can help it with certain PII elements protection, converting the formats if the formats are not ready for BigQuery, or converting it to a different file format. So once the data is loaded into raw, and you can see a similar pipeline on the top where we have streaming data coming in from the sources, whether they are read through APIs or these are pushed into our Kafka kind of infrastructure. And we have a Spark streaming application which is using the BigQuery streaming API and landing the data in raw in a streaming fashion in BigQuery. So once the data is all in the raw, we are combining the data set, creating the goal structures or the certified data sets. And once the data is available in the goal data sets, it is available for different use cases, whether it is the data scientists who are basically pulling the data using some PySpark jobs, using BQ storage APIs, or we have extracts that are being run through a Spark job, or there are some reporting use cases which we are enabling on Tableau, and all the ad hoc analytics is basically happening on BigQuery. So to kind of summarize here, so this talks about some of the challenges that we were having with our on-prem solution. So we have, like with our current on-prem solution where we had Hadoop and we had EDW ecosystems, we had a very complex operations. And then that kind of, and also with that kind of complex operations, we were unable to keep up with the data growth, and we were having issues with data latency due to the data moving across various systems. We had a very complex implementation since we had kind of a zoo of technologies and no common approaches. It was very difficult to kind of just manage the ecosystem. Data was hard to understand, and the data was kind of, the data quality was suffering because it was going through multiple hops, and the data existed in kind of multiple systems. And our infrastructure cost was really high because there was a lot of duplication that was happening. So, so the advantages of doing this in the cloud BigQuery ecosystem is that we don't have any upfront cost, and as we need kind of, as we are adding more and more to BigQuery, we are adding more capacity to our BigQuery infrastructure, and it is, so we kind of leverage the fixed slots within Kohls. So we started off with certain number of slots, and as we are kind of growing, storage is not a problem, but as we need more and more compute, we are working with our Google, and we are able to bring in more slots as needed. So it's kind of faster speed to market because of usage of the cloud services, and also as we are bringing in data, we have created some reusable components and functions that can help with file management or auditing. So those are kind of just everything is a template for us. So as we bring in more and more data, we just use a standard template, and we bring in all the data, and some of those standard functions are being used. The solution is elastic from both compute and storage standpoint, and it is hosted by Google. So with that, I bring Sam back to the podium again. Thank you, Sam.
Hello? All right. So thanks, Jazz. As you can see, he has the breadth and sort of depth of expertise in managing data at scale for a really large retailer. And I've been fortunate to, be part of that journey, and I've seen, how complex it can be. Sometimes it can be overwhelming, right? You have tons of different moving parts, and you have something already in place. So the ante is really high here, right? Is that you're going from something that's functional. Yes, you may not be extremely satisfied with it, and you're trying to move all of that to a completely different, system altogether without disrupting business. So this is why I say, what just happened, right? Because there was a lot of moving parts there, right? And in my experience with working with Jazz and his team, how do you take a monumental task like this? And in our discussions, he had a very insightful way of discussing it or describing it. This is a generational event. It doesn't happen all the time, right? So when you're there, this is going to be the once in a generation event that you're going to take something, your existing data warehouse, and move it to the cloud. So it is complex, overwhelming. You have a lot of different people, and you have to get buy-in from a whole bunch of people. How do you manage that? Obviously leverage your account team. All right, this is where people like me come in. We can help out. All right, if nothing else, when you get frustrated, you can just yell at me. That's cool. But it comes down to this, right? The first thing is you have to decide to move, right? It is a decision that you have to be firm about it, right? Like, it's not a wishy-washy thing. Let's go for it, right? You have to get stakeholder buy-in, right? That's one of the, in a complex transformation like this, you need to get buy-in across the board, right? So that is key, Then, one of the things that I saw Jazz and team do is go through diligently and identifying all the data sources, auditing it, making sure that they all make sense, right? Figuring out, what is it going to look like in, say, BigQuery, because they use BigQuery as sort of the central pillar of their data strategy going forward, all right? Then the simplest thing is identify a chunk, all right? Go the POC route, so that you can get, first of all, it allows your team to get comfortable with the new sort of semantics, the new technology, new paradigms that are involved in BigQuery, right? And build upon it. It allows you to sort of reimagine what your data warehouse is going to be in Google Cloud, right? And obviously execute. And I've seen them execute on this and flawlessly, right? It has been complex, but his team has done an awesome job on this. So in one of the previous slides, I said, what are the broad strokes that you need to consider when you are moving your data warehouse to the cloud, right? Talk to speed of adoption. So this is BigQuery, right? This is our solution to help you, be data informed at scale, right? So speed of adoption, BigQuery, you can get up and running very quickly, all right? If your analysts are very comfortable using SQL, go for it. It's available for you, all right? As Jazz mentioned, scaling as needed, right? So they started off with a bunch of fixed slots, and as their capacity and needs started increasing, they started increasing the number of slots available to them. So they could scale as needed. Insights analysis, again, they moved over some of the existing scripts, some of the existing workloads, and were productive as quickly as possible. And they also unlocked more workloads, all right? And they were able to deliver on this faster, all right, over much more amounts of data, all right? And it's also opening up, and there's another thing about BigQuery, right? Is that ML is becoming more and more important. So BQML, if you're not familiar with it, I would highly recommend looking into it. It allows you to execute machine learning models on BigQuery itself, which is pretty cool, right? And security, encryption at rest, in flight, and very fine-grained access controls using IAM. And with this, some customers go ahead and do it on their own. They have their deep expertise, their teams are built out, they can actually pull this on their own. And sometimes, you need additional help, right? And this is why at GSP, we allow you, we try to help you figure out, what is the best approach you can take. And sometimes you need a partner, right? And this is where I would like to introduce Dr. Phil, who is the president of Datametica.
Thanks, Sam. Thanks, Jazz, too. So let's get into migrating data warehouses. So why move to GCP? You've already covered a lot of that. There's some very good reasons to move analytics workload to GCP. It's best in class in our view. BQ is a killer app, and I think many of you know about it already. But moving a large data warehouse has some risks and challenges to the business. The business can be clearly severely damaged. If you screw up the migration of a data warehouse, you're going to know about it pretty quickly. So we started years ago moving these things manually, but you take a large, complex data warehouse or an infrastructure like Jazz presented, it's extremely complex to understand the data flows, contingencies, interdependencies, and to move that manually is risky because you can move a little piece and then break the rest of it in the process. So we started to figure out how do we move this in a more automated fashion quite a few years ago, and then how do we actually manage it? This is a wordy slide, sorry about it, it's so wordy, but you can take your time to read it. But really the reason to go to cloud is the unlimited scalability, the flexibility of performance you get, the ability to bring in all the different data sets, streaming, real-time, IoT, batch, structured, unstructured, in any sequence, any format you want, and any speed of latency that you need. And putting all your data in a single point of truth, there's no question, we all know that's logical, sensible, very helpful, and is definitely the direction that we're all going. The fast pace of features that are being added, you see constantly, the announcements at Next here, new features coming all the time. There's no way anyone else can compete with the speed of cloud vendors' innovation at the moment. And the new capabilities are coming every few weeks. And because you're on one platform now with the data in a single point of truth place, you can start to adopt those tools as they come along. And then you can focus, as Jazz said, you can focus more on the actual workload innovation. How do you drive value from the data rather than worrying about running servers, headaches of data centers blowing up in the middle of the night, which Keith and I had a few years ago. It's just getting you out of that headache and focusing on the value from your data, and adopt these new tools as they come. So cost is a big play, right? So you're starting to talk about large Teradata appliances of $20 million plus each in some cases, 5 to 6 years life, 20% annual maintenance on top of that, massive costs of buying and acquiring, and then all the people to run that. So the cost advantages of moving to cloud are pretty significant. We often do cost calculations for companies early on to show the cost benefit. And in the larger data warehouses, we see up to 60, almost 70% in some cases, 5-year cost savings. Even in the small ones, we see 20 to 30% cost savings. So going to cloud is very powerful, and I'm going to come back on that in a little while. And then you pay for what you use, of course. Also, we want to eliminate a lot of this legacy ETL. We've had ETL around for 30 years or more in some cases. It's very batch-wise thinking. It's not the modern way of dealing with data. IoT, streaming, Jazz mentioned that. The way we're going is real-time enterprise. Streaming is happening. It's something we have to embrace because the old ETL mentality is really holding us back. So we want to eliminate a lot of legacy ETL at the same time, and we want to be more labor efficient. So common challenges when you want to move a data warehouse that you have to address internally is budget and cost, of course. It's going to cost something to move. You will be paid back within a year or 2 or 3, at most typically you will see a payback. Sometimes even in a single year you'll see payback, especially if your data warehouse is end of life. If it's about to be end of life, the ROI on moving is very powerful, usually less than a year of payback. So how do you get started? What are the steps? How do you get your data there? Not only how do you get the data there, but how do you keep it synchronized? Because this is a moving train, right? Your existing system is live. There's data flowing all the time. It's changing. So you can't just take a snapshot and move it and expect it to work. It doesn't work like that. So how do you move it all, and how do you keep it all synchronized? And it can't take years to do this, because nobody has the patience to do a big multi-year project anymore. It has to take weeks and months. So those are the challenges you'll see. So we started to develop, years ago, some tools around that. First of all, how do you assess? How do you plan and assess this? I can, if you all here have a data warehouse, I can pretty much guarantee you don't know everything that's running on your data warehouse. There is jobs, ETL jobs, transformation jobs, user jobs. There's data being ingested. I can promise you, you don't know, and you have not documented everything that's running on your system. So how can you move it if you don't know what's running? So we developed a tool. It's a machine learning-based tool that discovers everything, literally everything that's running on an environment. So in a very fine-grained detail, and then it uses a clustering algorithm to cluster pieces of workload together so you can move a cluster at a time in a sprint model. And the next piece is how do you convert all the code, right? You can't just typically lift and shift a code base from a data warehouse. So if you took Teradata, it may have mloads, it might have SQL for users, it might have BTIC scripts, it might have ETL scripts that are non-standard SQL. And you're going to put them onto BQ to run, or on Spark or whatever on cloud. They have to be converted in some cases. So rarely can you, almost never can you lift and shift a data warehouse with all of the workload without some conversion. So how do you automate that conversion? How do you convert different dialects of SQL to a standardized BQ SQL or Spark SQL? So again, we have to automate that. Then how do you move the data, right? So how do you replace that ETL? How do you replace the data pipelines? How do we make that a more seamless, parametrically driven exercise? And finally, how do you validate the data? As you're in transition, you've got data in one data warehouse that's a live system. You've now got data on in cloud, and you've got to run in parallel for a period of time, because you need to know those two systems match. You need to know that your new system is giving you exactly the same results as the old system. With the same data inputs, you're getting the same data outputs, because your business users won't let you switch over until each phase is validated. So validation is a huge challenge, so we've automated that as well. So combining those tools, we can now do a sprint-based approach. We can now break a data warehouse down into many small sprints, where we can run each sprint in parallel on both systems for a period of time, and only move those users over for that sprint when we are confident that both systems are matching. The data's matching, the queries are matching, the outputs are matching, and performance is at least matching. And so when we've done that, we can move it and move the next sprint and the next sprint. So it's not a big bang lift and shift anymore, because that's way too difficult, too scary. We want to break it down into sprints, and now we can do that. Costs, are they really lower? People ask that. Hadoop was pretty cheap for storage on premise, but of course, we're now dealing with storage on cloud of between 1 and 3 cents per gigabyte per month, and getting lower all the time, and that is impossible to match with any on-site storage that I know of. The separation of compute and storage, so we now have storage that's very low cost. We can bring different compute engines. We can bring BQ, we can bring Spark, we can bring Python, we can bring whatever compute engines we want to the same copy of data on the same storage, and the storage is low cost. So there are significant cost savings if in a well-structured like Jazz. His new architecture is a perfect example of a very clean, simple architecture, single point of truth on the low-cost storage, and bringing any compute engine to that you need, and that's the way to go. So the promise is to take the frustration and cost out of these migrations and the anxiety of these large migrations. So you may have thousands, well, you will have in some cases many thousands of users using these legacy systems. We have to move them. without all the anxiety. And that's why we approach this in this sort of sprint-wise process. So we want to optimize it, we want to automate it, we want to use the tools to do the conversion of code, we want to do the automated tools for doing the validation and the data migration. And right at the bottom, we want to run in parallel, reduce risk and errors and mistakes. That is the only way we know of moving these large environments successfully. So the targets of this level of automation are here on the right. Clearly, a lot of Teradata. The Teradata is the most expensive, of course. Data warehouse and moving that has the biggest ROI of all of them. Netezza, if you're a Netezza custom, you know that IBM has end-of-life support on a lot of Netezza machines at the moment. There's a lot of people wanting to move Netezza. Oracle, of course, and Hadoop is still, as Jad's mentioned, there's a lot of Hadoop that needs to be moved, and even the old DB2 and Greenplum. So there's a lot of these tools have been written to automate the migration of these to cloud and all the associated pieces of ETL. So the time efficiency now through automation, we're seeing about a 2/3 reduction in cost and time. Time particularly because we can automate a lot of this, automate the assessment, automate the migration, automate the validation, and do it in a sprint-wise process, and about 50% cost saving or a little more sometimes. So now we can move things quicker and see the benefits that you saw from the Kohls example. So we're going to do some Q&A in a minute. I think, though, Sam, you want to come back for a minute?
Thank you. Yep. So thanks, Dr. Phil. As you can see that when we started off, right, we talked about a customer who was able to sort of deliver on their own, and sometimes you need a partner, right? Some of the key points that stood out in what Dr. Phil just said, one is automation. All right, a lot of this is dependent on automation. Like, can you get things to be reliable and can be done sort of quicker, right? The other was validation. Like, how do you validate whether you've been successful or not? So those are two really important points. And the third is, he did mention crashing data warehouses, so that is definitely scary. So bringing it all together, right? So when I started off, when I try to, distill what Jazz had just said about, especially their approach, right? We talked about deciding to move, getting stakeholder buy-in, identifying all data sources, POC, execute. Well, that's a start, right? This is the next sort of steps that you got to take, right? Move historical data over, point your sources, directly to GCP in this case. Update your tools and reports to point to BQ. Evaluate performance, all right? Benchmark it. Make sure that you're getting identical results across identical data sets. And yes, turn off on-prem EDW because that was the goal at the beginning of it, right? And keep building and making great things. So, it's complex, it's intense, and I've seen this, happen, right? But it's doable. I mean, prime examples, Dr. Phil has helped a lot of people, move over. I've seen Kohls move over as well, so it's definitely doable. It just takes effort, right? So we're going to go in a Q&A section right now. I'm going to act as the moderator, right? So if you have any questions, please feel free to step up to the mic, and we can, answer your questions.
It's not working yet. Somebody turn that mic on.
Hi.
There you go.
Yes, works. I have a question for Datametica, if I pronounce this correctly. Can you address a little bit, is that a static workload migration that you do? And how do you deal with context information? So for example, we've seen a lot of query differences that are only there because certain data types are there and certain transformations need to be applied when that is true. So it's not always possible to do, just a query A to query B type of rewrite, but rather it needs to be run in the context that the original query was run. And if you had to do that, or if you had to deal with that, how many times did you had to actually manually go and help the system rewrite?
And you're right. And also the data model may need to change in some cases, right? Because you're coming from schemas on data warehouses where they're not very friendly to these big data environments. So there may be very high numbers of joins, there may be concurrent reads and writes going on at high volumes. So there are some changes that have to be done to both code and data model and user queries. in some cases. I would say that that's getting less and less. The need to make changes is going down quite quickly now, because the early days of the cloud tools, they were not tolerant at all of some of the data structures and schemas that were on data warehouses. Now the BQ particularly has advanced a lot. So we're seeing less and less changes to make the same workload move without changing schemas and code. But of course, if you do want to change something, change the formats of data, the schemas of data, and there may be performance tuning. There is a little bit of manual work. So it depends. So sometimes it's highly automated, sometimes it's 25% or so manual work of cleanup, but it's very workload dependent. But the degree of changes we're seeing is going down as BQ becomes more tolerant of.
I think sometimes it's just legacy stuff that none of the modern systems will implement.
Yeah,
so those will always have to be dealt with.
Yeah. There is some manual work. Yeah, this is not entirely automated.
Thank you.
Another one. Hard to see. Somebody's coming down. Maybe two, maybe three. George?
Hi. Hi. Thanks for the presentation. I'm curious to know about the end user experience, the types of tools, how many end users did you have to support in the conversion, what their tool compatibility experience was. And then my second question would be, what's your experience at estimating slot counts and what you thought it would be versus what your forecast is going to be?
Yeah, so talking about the slot counts, right? So there is a calculator that Google has, which basically helps you look at your current on-prem systems and come up with some kind of an estimate. If you run a similar workload in the cloud, this is how much it will take to run it. Again, you should take that with a grain of salt, because sometimes these numbers are really big in some cases. And we will, basically we started off with certain use cases and worked with Google and said, if we have to do certain workloads, how much do you think it will basically be on those slots? So we started off with that, and we started to bring in more and more use cases and add to those slots. So we have not started off with a very big number. So we are going with a smaller number. And at this point, so it's like halfway done through the migration, I think we are kind of trending towards just getting to a number which is going to add a lot of value to our final migration in terms of cost.
And then my first part was about the, I guess, the end user tools and the types of tools that you've moved on to the platform, like, Tableau and MicroStrategy, and what that experience was. Did you have to rewrite reports to take advantage of the new data model, or did they come over more seamlessly?
Yeah, I think the approach has been that we don't want to just simply lift and shift whatever we have in the cloud, whatever we have on-prem, because that's going to be very difficult to support in a longer run, because how the data is in 6 normal form, or it's kind of normalized in some of our systems. As we bring it on, we're trying to normalize it, denormalize it as much as we can. And there is a change that is that we are asking our partners and business stakeholders to make as we are moving to the cloud. So in terms of tools, yes, we have brought in some of our reporting tools to the cloud and making that available. And we have also enabled a lot of tools which will enable self-service on the cloud. And Dataprep is one of the examples where we basically provide certified data sets to our stakeholders and let them have it from there, right? They can create their own structures and create the reporting that they need eventually from that.
I was going to say one quick question. A lot of newer migrations, though, are trying to keep the same data model and same tools, because change management on the human side is the biggest issue. So what we do is, that is entirely possible now, but there's usually an optimization phase afterwards where things are not working well. There's some long-running queries, some issues. So there's a tuning phase.